Dear students, let us continue the study of the decimal number system. Yesterday I told you that there are different number systems which are commonly used uh, in computers as well as day-to-day life. So the decimal number system is commonly used in the day-to-day life. You are familiar with any decimal number, right? So there two terms are usually used, that is LSD and MSD. What is this? LSD and MSD. Now LSD is the least significant digit and MSD is the most significant digit. Let me consider one example. Say for example, let me consider a number, say 1091, 1093. Consider 1093. Now this is a decimal number. Now you can represent this number as in terms of base 10. So base or radix it is called. So we are representing this number in terms of the base 10. So the number may be represented as 1 into 10 to the power 0, 1, 2, 3. So plus 0 into 10 to the power 2 plus 9 into 10 to the power 1 plus 3 into 10 to the power 0. So this is how we are representing. Now in case of this 10 to the power 3, so this is having the maximum value. So the number corresponding to it, the multiplication number corresponding to this maximum value of the power of 10. So that is called the most significant digit, right? Similarly, the 10 to the power 0. So this has a lowest value. So the number 3. So this is called the least significant digit. So this is in case of any whole number. Now suppose if the same number, now you are considering one more example, say, so say 756, right? 1093.756. Now here you can continue this. Now 10 to the 1 into 10 to the power 3, 0 into 10 to the power 2, 9 into 10 to the power 1, 3 into 10 to the power 0. So continue this. So plus 7 into 10 to the power minus 1 plus 5 into 10 to the power minus 2 plus 6 into 10 to the power minus 3. So now the most significant digit remains as it is before, but the least significant digit it changes. Now this number, that is 6, is having 10 to the power multiplier 10 to the power minus 3. So this becomes the least significant digit. So this you must know. Now, so this is about the decimal number system, and other things, addition, subtraction, division and multiplication, all other things you are familiar with it. I need not have to explain it, and you are commonly using in your day-to-day transactions, right? Now let me go to the binary number system. Now as the name itself indicates, binary number, it consists of only two numbers, 0 and 1. So any number which is it can be represented by two digits only, that is a 0 and 1. So that's why it is called as a binary number system. Now in case of a binary number system, it can be represented as a decimal number. You can convert a binary number into a decimal number or a decimal number into a binary number. Now say for example you let me consider one example, say 759, say. Let me consider a smaller number. Let me consider only 7, say. So this is here this is a decimal number. How we are going to represent this number in terms of a binary number? Now for that, what you have to do is go on dividing this by 2. So 7 divided by 2, so it is 3 times. Write the remainder by the side, right? So similarly, go on dividing this number 2. So this is 1 and 1 remaining. So again divided by 2 till 0 comes. Go on dividing the number by 2 simultaneously. So now write the binary number from bottom to top. So 7 in decimal number, so that can be represented as 111 in binary number, right? So 111 like this. Say for example, let me consider one more example. Say 15. Go on dividing by 2, 7, 1, again divided by 2, right? So it's 3, remainder is 1, again divided by 2, quotient is 1 and remainder is 1. So 2, 0 and 1. So write the binary number from bottom to top. So 15 in decimal number, it is represented as 1, 1, 1, 1 in binary, right? So this is how. So in some books this bracket is not there, right? The bracket is not inserted. So even you can write it in that way also. But it is convenient to write it in terms of by putting the bracket. So this is a decimal number that is equivalent to 1111 in a binary number, right? So let me consider one more example, say 21. Go on dividing it by 2, so 10, remainder is 1, so again divided by 2, quotient is 5, remainder is 0, 2, this is 2, quotient and remainder is 1, 2, 1, 0, so again divided by 2, 0 and 1. So write this in terms of within bracket. So 21 in decimal number, it can be written as 10101 in binary. Okay. So this is how you can represent or convert a given decimal number into a binary number. Now this is in terms of say whole number or integers. Now what about the fractional number? Say for example, there is a number, say 0.31. How we are going to convert it into a binary number? Say 0.31, 0.31. So the fractional part you are considering. Now how will you how you can represent this number to a binary number? Now, so what you have to do is multiply this number by 2. So go on writing the value. So it is 0.62, 0.62. There is no fraction, right? So if you take that again into 2. So it is a 1 point. This is a 4. 2 6 are 12. So 1.24. Now you write this as fraction. You take only the decimal part, 0.24 into 2. So 0.48. Right? Similarly, 0.48 into 2. So it is a 0.96. Remainder is 0 and so on. So now you can write you can go on multiplying it 3 or 4 times. So while writing from top to bottom you must write. So 0.31 of in decimal number system that can be represented as 0.0100 in binary. So this is how you can write any or you can convert a decimal number into a binary number. Now let me consider one more example. Say 25.375. You have to convert this number into a binary number. This is a decimal number. You have to convert it into a binary number. So now how will you do that? So first you consider the integer part, 25. So go on dividing it by 2. So this is 12, remainder is 1, 2, this is 6, remainder is 0, 2, 3, remainder is 0. So again divided by 2, 1. So this is a 1, then 2, 0 and 1. So you can write this. So this is the whole part or whole number or the integer part. Now what about the decimal part? So decimal part, as I told you just now, go on multiplying it by 2. So you take it separately, 0.375 into 2. So this is a 0, 15, right? So 6 is a 7.750, write the remainder as 0. Now you take 0.750, multiply it by 2 again. So this is a 1.500. So this is a 1. This 1 you should write it as a remainder. Now you take only the fraction part 0.500 into 2. This is 1.00. So this is the last step. So remainder is 1. Therefore you can write the binary number as, say, this 25.375, that is equal to this is a 11001.011. So this is how you are supposed to write the binary number. So the equivalent of 25.375 in binary, it is 11001.011 in binary system.